Bismillahirrahmanirrahim. I welcome class 10th in my lecture series for chemistry. We are on chapter 11, that is organic chemistry, and our topic for today is the functional groups containing carbon, hydrogen and oxygen. We have read about the three classes of organic compound belonging to this category in our previous lecture, and we will discuss about the next three classes in today's lecture. So this category contains 6 classes of organic compounds, and those are alcohols, ethers, carboxylic acids, aldehydes, ketones and esters. We have discussed about the alcohols and ethers in our previous lecture, and we will discuss next 4 classes in our today's lecture. So starting from aldehydes, what are aldehydes? Aldehyde is an organic compound containing CHO group. Now in the aldehyde we have a carbonyl group, that is C double bond O group, which is attached to the hydrogen atom on one side and attached to the alkyl group on the other side. Aldehydes are generally represented as RCHO. This is the condensed structural formula for all the aldehydes. This is the representation for all the aldehydes, and you may see that this C double bond O is the carbonyl group. At one side of the carbonyl group hydrogen atom is attached, and on the other side an alkyl group is attached. Now for an organic compound to be an aldehyde, it is necessary that this carbonyl group must contain at least one hydrogen atom attached to it. This C double bond O H is the functional group for all the aldehydes. Examples for the aldehydes include acetaldehyde. This acetaldehyde is also called as ethanol. Why ethanol? Why we use the prefix eth? It is because that this compound contains 2 carbon atoms. Another example of aldehyde is the formaldehyde. This formaldehyde is also called as methanol. Now, since it contains only one carbon atom, therefore the prefix meth is used here. Now, if you look at these two names, then you will see that these two names are ending with AL. So this AL is a suffix here. Any compound which is ending with AL will be considered as an aldehyde. We have read before that suffix denotes the class of organic compound. So this Al suffix is representing the class of compound, that is the aldehyde. Next class of compound belonging to this category is the ketones. Ketone is an organic compound containing carbonyl group attached to alkyl groups on both sides. The functional group in ketone is the carbonyl group, and the condensed structural formula for the ketone is RCOR. This is the representation for all the ketones. Here you may see that in the middle a carbonyl group is present, which is attached to an alkyl group on both sides. Now in ketones, these two alkyl groups may be same or may be different. Examples for ketone includes acetone and the butanone. Acetone is also called as propanone because this compound contain 3 carbon atom, so therefore the prefix prop will be used here. Now, as this compound contains 4 carbon atoms, so the prefix but would be used here. Now, if we want to locate the position of carbonyl group on in this compound, then we will first number these carbon like this. Now, after numbering, you may observe that the carbonyl group is present at the second position. So, this compound may also be called as 2-butanone. Now, if you look at the names for these two compounds, then you will see that the names for these two compounds is ending with the suffix O-N-E, on. So this means that all organic compounds ending with the suffix O-N-E will be a ketone. Now, what are the carboxylic acids? The carboxylic acid is an organic compound which contains COOH group, and this group is attached to an alkyl group. Functional group of carboxylic acids is called as the carboxyl group. Here you may see that this is the structure of a carboxylic acid. This C double bond OH is called the carboxyl group, and any organic compound in which the carboxyl group is present, that compound will be classified as the carboxylic acid. Now you may see here that the carbonyl carbon of this carboxyl group is attached to an alkyl group on the other side. Carboxylic acids are generally represented in the condensed form as RCOOH. Now here the R may be hydrogen or it may be an alkyl group. Examples for carboxylic acids include formic acid, that is present in the bite of an ant. This formic acid is also called as methanoic acid. Second example of this carboxylic acid is acetic acid, which is present in vinegar. Now, since this compound contains 2 carbon atoms, so it is also called as ethanoic acid. Now, if you look at the names of these two compounds, then you will see that the names for these two compounds is ending with OIC, suffix OIC, and followed by the word acid. So all the classes or all the compounds whose name is ending with OIC followed by the word acid will be considered as the carboxylic acids. This C double bond OOH is called as the carboxyl group, and this carboxyl group is the functional group of all the carboxylic acids. Now moving towards the last class of compound belonging to this category, we have esters. Now what are esters? Esters are the organic compounds which contain C double bond O group attached to an alkyl group. The functional group in esters is this. Here you may see that carbon is attached to an oxygen atom through a double bond, and to another oxygen atom it is attached through a single bond. At one side of this group an alkyl group is attached, and on the other side an alkyl group is also attached. Now if this side contains hydrogen, then it will be called as carboxylic acid. However, if it contains alkyl group, then it will be called as esters. Esters are generally represented as RCOOR. Now this R, this one, may be hydrogen or the alkyl group. This R should be an alkyl group for it to be an ester. In the esters, this oxygen atom should be attached with an alkyl group in order to classify that compound as ester. If this oxygen atom is not attached to an alkyl group but attached to a hydrogen atom, then that organic compound will not be classified as ester but as the carboxylic acid. Example for esters include methyl acetate. Now, this methyl acetate is also called as methyl ethanoate. This group is called as acetate or ethanoate. Another example for the esters is the ethyl acetate. This ethyl acetate is also called as ethyl ethanoate. Now, this group is called as ethanoate, and we know that CH3CH2 is called as ethyl. Now, if you look at the name of this compound, then you will observe that it is ending with the suffix -oate. So, all the organic compounds whose name is ending with OATE will be classified as esters. So, these were the classes of compounds belonging to the category containing carbon, hydrogen and oxygen as a functional group. Now we will discuss about the another functional group containing carbon, hydrogen and nitrogen in our upcoming lecture. This was all for today. Thank you for being with me.